Sir, we are live now.
Okay. So, very good morning to all the students those who are online. Uh, I, Dr. Vankanyaria from Atma University. Today I am going to take your the coursework lecture on natural product chemistry. So, first of all, start before start, we are just discussing the what is the natural product, what is the importance of natural product, need of natural product in drug discovery. This is the special branch of chemistry, and this is the special branch of organic chemistry. Because chemistry of four branches, mainly organic, analytical, inorganic, and physical. This is the part of organic chemistry, and mainly it covers the drug discovery part in organic chemistry. Today I discuss on the how we can reach to a new molecule from plant. So I gave you the name is the from plant to molecules. So first of all, I'm discussing what is natural product. So I derive the definition. It's anything found from natural resources or anything found in living organism is called natural product. It means it covers either animal, fungi, insect, medicinal plant, etc. So why we study the natural product in chemistry? What is the importance of natural product chemistry? The history of natural product. We are using this natural product from ancient science, ancient era. Mainly we call it Ayurveda because Ayurveda has a many branch. And also we can call that our allopathic system of medicine, Unani system of medicine, Siddha. That's all are the branch of Ayurveda because all are branch but from Ayurveda. So why we need this? You can see in the PPT. What do all of these have in common? You can see the pictures, different pictures of drug molecule or drug already available in market, modern market. First is the product of Bayer. Second is the wind blasting and wind crystal. Dioxin, Taxol, atropine, CBD cannabis extract, vincristine and vinblastine that are found in Vincarosia. They call it in Gujarati it's called Barmasinochol. This is the derived from natural resources. Also, we can say that currently the 70 to 80 percentage of drug molecules are coming in from the natural resources. So our dependency is more on natural products. Currently we are eating this source, roti, sabji, so all are natural resources, and it has capacity to build your body. So that is a very important part of our life. So some introduction of natural resources, why it is important that the ancient Ayurveda system of medicine from reference to scripture like Vedas, Samhita, and Purans. Already many drug are referenced or found a reference in this scripture. Currently, we are looking that there are about 391,000 species of medicinal plants currently known to science, already reported in our flora, whether that is the Indian flora or other foreign flora. That is the work of botany and pharmacognosy department to identify mutation of plant. In our chemist, it means in our chemistry, our work is to identify a molecule from plant and which are responsible for the disease. Currently, our dependency, why it is we are dependent on this natural product because a new molecule or that are which are useful in drug discovery. It is estimated that 25,000 to 75,000 plant species are used for traditional medicine that are treated to human disease. Already reported. Either it is extract, either it is a raw material, either it is a semi-synthetic molecule or synthetic molecule. Before 5 to 6 years, also we are looking for iodine in COVID-19. Department of IUS so published a guideline to take a scholar of Kala or DOE. That is the best medicine for fever. It increases the immunity of our body. That's why, because it stops the disease before entering in our body. So that's why it is necessary. You can all of you are known about what is the difference between Ayurveda system of medicine and allopathic system of medicine. In allopathic system of medicine, we are using a single molecule or a combined molecule, maximum two or three. Whereas in Ayurveda, there is a bunch of molecular available. Already you heard that when we take a milk with turmeric, it means that turmeric with a milk, turmeric with a jaggery, turmeric with a honey. This all these formulations have different activity in our body. Molecule it means a plant is same. It is a turmeric. But when it is taken with a different food, its activity is the different. So in the presence of one molecule, the activity of the second molecule is different. It's called a bio-enhancing effect or bio-enhancing activity. So it's contain a complex molecule. We cannot identify many thousand molecules currently from the plant. So nature products have proven to be a lead source of novel biological active compound. So currently the researchers have focused their attention on medicinal plants. Many companies, MNCs, have focused the drug discovery from natural resources. And they have established the R&D setup, and they have spent 1,000 crore rupees behind. So need to nature product because of nature product are the source of most complex and fascinating chemical structures. Also, nature products represent the natural biological activity, whether it is a single compound or as a complex nature. Already I given one example of turmeric. Its effect is different when it is combined or as a single molecule because of curcumin. That is a part of that is the one active molecule which are found in turmeric. Nature product can be an effective bridge from tradition to modern scientific development. Before our ancestor, they are using only one source is the Ayurveda. You heard about the name of Sushrut. Sushrut was the first surgeon in the world. They had done a surgery before 1,000 years ago. So we can predict, we can think that they are using different natural resources in the surgery. We are focusing on their operative system, which molecule they had been used for the as a anesthesia, which molecule they had used for clotting of the blood. We are still we are searching. If we found, then that is the drug discovery. It can be effective bridge from tradition. That's why that is the effective bridge. World. What we are currently doing, we are focusing this ancient reference and apply to in our modern research in molecular biology, genetics, biotechnology, and pharmaceutical science. The era of modern scientific discovery started in the 18th century, where the crude drugs were still being used as a powder, simple extract, or tincture. The era of pure compound in 1803, a new era of history of medicine. Isolation first, the isolated morphine from opium poppy. That's opium. Strychnine. Other example is strychnine, quinine, caffeine, nicotine, atropine, and cocaine. You can say these all molecules are from alkaloid, uh, alkaloid part. In 19th century, the chemical structure of many of the isolate compounds were determined by scientific method. In the 20th century, it means the 100 year, the discovery of important drugs from the animal kingdom, particularly the hormones and vitamins. In addition, the microorganisms have become a very important source of drug. Compounds from natural source play a significant role in modern medicine because of the provide a number of extremely useful drugs that are difficult, if not possible, to produce commercially by synthetic technology, and there are the commercially available in the market. Natural source also supply basic compounds that may be modified slightly to render them more effective and less toxic. So this is the importance of natural product, and this is the importance of natural drug. If we are talking that there is their utility as a prototype or model for synthetic drug, which are physiological activities similar to original ibuprofen, aspirin, etc. We are looking the historical perspective, the milestone example of natural product. You can see in the slide, it's a morphine, which are found in opium, quinine, which are currently used in the market as an anti-fever, malaria drug, and it is found in cinchona bark, cinchona chalk, cocaine from coca, digitoxin, it's a foxglove, found in or isolated from the foxglove, reserpine, ruofula, texifolia. It is used in a hypotensive drug, used as a hypotensive drug. Second is the milestone example, that is the vinca leucoblastin. And second is the vincysteine. It's also called vincysteine and vinblastin, and it is found in Vinca rosea. It's called Barmasi. In Gujarati, it's called Barmasi, which are used as an anti-cancer drug. Currently, it is used in chemotherapy, cysteine and blastin. So we are dependent in cancer. There are two molecules are available. One is the taxol, second is the vincysteine, and also these two molecules are found in nature. No other molecule, no other synthetic molecule which are useful for anti-cancer. Recent discovery in nature products are Paisley Texel is used as an anti-cancer agent, and it is found in plant. It's called Texas brevifolia. Artiether is also mentioned in herbal Chinese uh, flora, which is used in anti-malarial drug. And plant name is Artemisia annua. So this is the different molecules found in different plants. There are thousands of molecules are reported from literature. This is just an example. You can see the some milestone in nature photochemistry: atropine, caffeine, scopolamine, acetylhexyl, taxol, ephedrine, reserpine, quinine, camphor, cocaine, cholesterol. This is the combination, this is the mixture of milestone example in which some of this molecule is used as a drug molecule, whereas other molecule is very active. So difference between active molecule and drug molecule is there. Drug molecule is give only and only positive pharmacological effect or pharmacotherapeutic effect. Whereas active molecule gives a positive as well as it can give a negative effect. For example, caffeine. Caffeine is not a drug molecule, but it is a very highly active molecule. Second example is the nicotine. They are found in tobacco leaves, which are highly active molecule, can affect on our mind. There are this example is thousands of examples are available in the natural product. Either that is found in medicinal plant or insect or animals. Secondly, I show you second example. You can see there are different examples which are found in different species. We have seen the different example from medicinal plant. This is the example which are found in soil. It is a bacteria, but it has a molecule because in our body every movement are based on a chemical compound. Not in our body, all living organisms are working or not working that are based on chemical compound. Is the bacteria or drug which are found in the bacteria. It's a streptomycin, tetracycline. You can see that the structure or complexity of structure of nature. Streptomycin, tetracycline, neomycin, erythromycin, and chloramphenicol. These all drugs are currently used in the market, in the modern market, but is found in natural resources. Discuss the difference. Example is the diagram of botulinum toxin, and that is the other example of bacteria. We can see the different example. Evergreen drug penicillin, which are found in this bacteria. It's a Penicillium kairos genome. You can, for example, cephalosporin. This is the core structure of cephalosporin. You can see the chirality of the molecule. In chemistry, if one chiral center present in the molecule, that is the very tough to synthesize in the lab. That is very tough. You can see in the picture. There are many chiral available in the structure. So its stereochemistry is very tough. So its synthesis is very tough. That's why many molecules are used as a directly semi-synthetic drug. If you are fully synthesized, then there is no problem. If it is a semi-synthetic, then we have to take on a part of the molecule from natural resources and later we synthesize the next part in the lab. So it's called semi-synthetic drug. For example, Taxol. This is the gracefulin, lovastatin, ergometrin. This is the example of fungal secondary metabolites. This is the structure of cyclosporine. Now, other molecules which are found in plant is a pastry taxol. You can see the structure of taxol. It's found in Texas brevifolia. This is the evergreen milestone example in nature product currently used as an anti-cancer agent. So this type of molecule we cannot synthesize in lab, and it's take a long time to synthesize in lab. This is the example of vinblastine. This is the structure of vinblastine. It's found in Catharinus roseus. This is the bar muscle. Artemisinin annua. This is the artemisinin and artemether, anti-malarial drug. This is the paper somniferum. It means ophium. It is found in the ophium capsule. It means its fruit. The example of morphine. You can see the stereochemistry of this structure. So this is the different example. And if you are talking to from animal, and this is the example of molecules of chlorotoxin. This is the one type of protein which are found in scorpion. This is the ribbon diagram of the chlorotoxin that are very toxic compound. Currently, it is used to bind a anti-tumor cell because in human chlorotoxin bind a preferably glioma brain cancer cell. Glioma is a type of tumor that forms in the brain or spinal cord. It can often become malignant, which are terms used to describe cancer, which has a poor prognosis, and it is prone to spreading the different area of the body. In here, chlorotoxin only bind with the tumor cell and not with the normal brain tissue. That's why these features has allowed the development of new method to treat, diagnosis, and remove the several different type of cancer. So this is the importance of a toxin that are found in the scorpion. This is the importance. So researchers have focused their also their research on an animal. This is the example of chlorotoxin which are bind to cancer cell. You can see in the picture it is bind with cancer cell, not with a normal cell. So this is the uh, examples of compound, natural compound which are found in animal. These are the other example structure. It's a T-proteid and its synthetic derivative, plazapine and captopril. It is a toxin and produced by the pit viper. because it is a very high toxic. That's why it is not used as a directly in the drug as a drug molecule. However, it is a very good biological activity lead to the development of synthetic antihypertensive drug like silazap and captopril. This is the starting material. You can say that is the work as a starting material for the synthesis of these two drugs. Also, researchers have found the medicine from the sea. It's a monotoxin, or it is a patent molecule. It is a 743, but its structure is very large. So we we can imagine what is the effect of natural compound. So we have question why this type of molecule are present in the nature. What is the role of this type of molecule in the nature, in the living organism, either it is a plant or animal or human, all living organism. We can say that in all living organism. What is the role of this metabolite? Because God has gifted to this type of molecule to everyone. So we are back to our PPT. This is a different example. Morphine strychnine. Quinine. This is the structure of this compound. You can see its isolation time. It means era. It was isolated in 18th century and structure identification that are did in 1925. It takes almost 100 years. Why? Because of currently we have a different spectroscopy and chromatographic technique for separation and identification or characterization. At that time, this is not available. So they find their structure by different traditional method in organic or by the using of organic and inorganic qualitative test. And its synthesis is possible in 1954. Hexam, the strychnine, which are isolated in 1818, and its structure or characterization happened in the 1946. It takes almost 125 years. Like quinine, it was isolated in 1820, and synthesis are in 1944. For cocaine, is the different example of salicylate cholesterol, which are the pioneer molecule in the nature of cholesterol. And we hear the many times this word in our social life. This structure of cholesterol is the class. Its class is steroid and triterpene because the steroid have also two types. One is the phytosterol, second is the steroid, and third is the mycosterol. This is the animal steroid, cholesterol. Euphedarin, it is the aromatic alkaloid from Euphra isinica. the structure of ginseng side RS2 is also mentioned in the uh, Chinese herbal flora, and it is used in Chinese traditional medicine. You can see the structure of brevetoxin A is the red tide toxin from Gymnodium grave. You can see the structure of this molecule. It is not possible, like impossible. That's why it took a time to synthesize this type of molecule in the brain. The chirality, stereochemistry of the structure. Maximum, we are seeing the work with 5 members, 6 members, 7 members heterocyclic ring. It contains the 9 heterocyclic. This is the structure of textual dynamism A. Currently, we are using antibiotic polypeptide from Micromonaspora vaccina. These are different examples you can see in the picture. So, we discussed that what is the importance, what is the history of the nature product, definition of the nature product, and role. Why it is more important? Because it contains this type of, it's called a complex molecule library. Before 5 minutes, I asked one question is that what is the role of this metabolite in our body or in living organism that have a particular activity, and why this is the available in the living organism. That is the one role of each and every molecule. So this type of molecule called a primary metabolite and secondary metabolite. Question is that what is the primary metabolite and secondary metabolite, and how they are produced in living organism. You can see the malonic acid pathway and cyclamic acid pathway, just like a photosynthesis process in the plant. We studied this a basic phenomena in our primary and higher secondary education. It's called Prakash Sansleshonic. Yeah, this is the basic photosynthesis process, but here it is the cyclamic acid pathway and malonic acid pathway. This diagram shows how molecules are produced in living organism and what is the system and how it is produced by a body, because we are not synthesize this molecule in our body daily to daily, but body automatic produce, or this is the cycle. Each and every hours body work or enzyme work, and they are producing this type of molecule. You can see in the photosynthesis process, they are first use the carbon dioxide and water. The process happens in photosynthesis. Its first product is carbohydrate. It means energy. It means a glucose. It contains glycoside, mono, oligo, polysaccharide, etc. This type of compound. By this carbohydrate, a body produces erythrophosphate, and by ischemic pathway, it will produce uh, it is produced phenylpropanoid, coumarin, lignin, and phenol type molecule. Other side ischemic pathway, with the help of flavonoid and tannin, is included in malonic pathway and produce a triterpenoid, terpenoid, diterpenoid, steroid, etc. With the help of enzyme coenzyme, other molecules which are present in the body. By Krebs cycle, it releases the carbon dioxide and produces amino acid, which are a very useful secondary metabolite in our body. Amino acid using the ammonia NO2, it means the nitrogen containing compound and produce alkyl nucleic acid, polyphosphine, and a heterocyclic compound protein. Other side, a reactive cycle create energy and H2, remove H2O, remove energy. The help of acid and coenzyme. Uh, Third cycle is the polypeptide pathway, and it is produce phenol, quinine, polyacetyl fatty acid, and lipid. So you can see the many type of class of compound which are produced in living organism. How they are produced, you can see in the picture. So this cycle create a many, produce a many primary as well as secondary metabolite. Each and every enzyme, protein, peptide, amino acid, alkaloid, phenolic compound have different role and responsibility in living organism. So, we are discussing primary metabolite. You can read in the slide. Primary metabolite are compounds that are commonly produced by all plants and are directly used in the plant growth and development. Repeat, those compounds which are responsible for a growing body. So it is necessary that this type of compound are present in all living organisms. Plant contain DNA, animal also contain DNA. It means a human, we have also DNA. It means without this type of compound, body cannot grow. It means this is necessary to present in all living organisms. That's why this is the primary metabolite. The main primary metabolite are carbohydrate, protein, nucleic acid, and lipid. Without this class, it means without carbohydrate cannot live. Without protein, living organism cannot survive. Without nucleic acid, it is not possible to survive. Without lipid, it is not possible to live a life. So this is the a primary metabolism. This is the description of the primary metabolism. Already we studied in our previous semester of UG and PG. So this is not I'm not taking time too much in this carbohydrate, protein, enzyme, and nucleic acid. So this is the primary metabolite. Now the secondary metabolite. So what is the role of secondary metabolite? Secondary metabolites are organic compounds that are not directly involved in the normal growth, development, or reproduction of an organism. Means what? It means it may be present in the living organism in one species, and it may be this the absent in other species. But it cannot affect on the growing of body or growing of living organism. That's why that is the secondary metabolite. I repeat its definition. Secondary metabolite, those compounds which are not responsible for direct or normal growth of a living organism or development of the living organism or reproduction of organism. Even though they are present in the living organism. So what is the importance? Importance is it gives a particular characteristic of living organism. They are protecting a living organism. Already I gave you one example, chlorotoxin present in the animal. It means the scorpion has this compound to protect itself by other, from other. So this is the particular characteristic of secondary metabolite. I will give you other example. A different plant have different color, different fruit. Its fruit taste is different. Some of the sweet, some of the sour. Different molecules. This whole plant can live without this molecule which are present in other. For example, mango tree gives a mango and it contains different secondary metabolite. Whereas a tea, tea plant, it contains a caffeine, but mango tree does not contain a caffeine. So mango tree can live without the caffeine. There is no effect of caffeine for the growing of body, but it gives a characteristic. Some of the plant are bitter in taste, some of the plant are sweet in taste, some of the plant are sour in the taste. So different plant have a different metabolite, and from this metabolite it has a different characteristic. Many plant contain aroma. It's a tulsi. It's called Ocimum septum. It contains a volatile compound. Some flower is highly fragrance. So we can say there is a high amount of volatile or terpene types molecule it has. Some plant have a volatile nature, some plant have a fixed oil nature. So different plant has a different activity, different taste, different the height and shrub. So it means a different animal. You can see the example in also in animal. An ant bite us at a time. There are left the formic acid in our body. So it contains a formic acid, chlorotoxin. It means scorpion has contained a chlorotoxin. So this is the example. Yes, ambergris. This is the famous example of vomit of whale. Now this ambergris, you can hear this name in daily news. in your social life. Number is currently used in the perfume industry, also called a vomit or well. So different living organisms contain a different examples. These metabolites occur irregularly or rarely among plants, and that have no known general metabolic role in the plant, not made through metabolic pathway common to all plants. Secondary compounds are grouped into classes based on the similar structure and biosynthetic pathway, or the kinds of plant that make them. The largest such classes are the alkaloid, terpenoid, steroid, and phenolic. This type of molecule you can hear or studied in your previous semester or previous study. This is the function of secondary metabolite. The most common role for secondary compound in plant are ecological role that govern interaction between plant and other organisms. Many secondary compounds are brightly colored pigment like anthocyanin that color flower red and blue. These attract the pollinator and fruit and seed disappear. Nicotine and other we discussed this type of compound. Nicotine and other toxic compound may protect the plant from herbivores and microbes. So this is the function, this is the role of secondary metabolite in the living organism. Can classify like the chemical classification of drug is dependent upon the grouping of drug with identical constituent. Is the main class of nature product derived below, like plant pigment, lignins, protein and vitamins, carbohydrate, glycoside, lipid, oil and fats, terpenoid, steroid, fatty acid derived substance, alkaloid, phenolic compound, flavonoid, tannin, and volatile. So this is the main class of natural product there. Therefore, the more description about the secondary class. So, so what is the role of chemist? What is our role? What is our role as a researcher? So where we can find this type of molecule. So you can see the from plant or animal or bacteria. So this is the basic steps of hunting. This is our starting steps of our chemistry. What we can do, the first steps in our lab, how we can identify, how we can characterize, how we can isolate, how we can separate, and how we can call it is active or not. Okay, so this is the basic steps to screen a plant molecules. So first steps is you can see in the slide, it's a hunting for the active molecule. How we can find the active molecule from plant. So we have to do a plant collection. This is the first steps. Second is the drying and grind the sample. Before that, always you are all you are PhD scholars, so you have to reference before plant collection. You have to referencing of this molecule. You can find your reference from our ancient literature, our folklore reference, or in a scientific reference. What is the scientific reference? It means from research article, patent, etc. What is the ancient reference? It means the Charak Samhita, Social Samhita. And what is the folklore used? For ancestor use this drug or plant, and we can take from. So this is the three type of referencing available in our chemistry. So you have two. First step is the referencing. Why you choose this topic? Why you choose this plant? Is the necessary to give answer in your first DPC? Why you take this plant? Is the question. So first we have to decide the role of your nature product. Second is the plant collection. This is a necessary part, and this is the very important plant collection because a month and year and seasonal effect are affected on these steps. If we collect the plant in January and if we collect a plant in December, then metabolite may be changed. That's why it is necessary to mention that month and season in your thesis. So first step is the plant collection. Second is the identification of this plant. In nature product chemistry, this is a very necessary part to identify the plant. It is the work of botany department or of pharmacognosy department. You can send your sample to this both department. They will identify your plant and your certificate, issue the certificate. Third is the drying and grinding sample. First we have to dry, pseudo dry. But one limitation of this step is that if you want to work on volatile compound, then your drying step is we may skip. If you want to work on volatile compound of plant, then you can skip this steps. Why? Because if we are drying this material, the volatile compound will be evaporated. So second step is dry and grind sample. Third step is the extract the sample with various solvent. It's called fractionation. I give you one example. If you add because this is a dependent on polar and non-polar compound. One thumb rule is there, like polar like and like dissolve like. If you want to work on non-polar compound, you must use a hexane diethyl ether or petrolither type compound. If you want to work on polar compound, then you must use to methanol, water, acetone, acetonitrile, this type of solvent. But here fractionation is very important. So first of what I will show you the next diagram so you can see you are easy to understand. So this is the first biomass. It means our plant. It is our any living organism. Second step is extraction with the help of different solvent. The different so you can use the different solvent on the basis of which you want to work from non-polar to polar, polar to non-polar, mid-polar, etc. So you will get a crude extract. And second of all, determination of biological activity. This is the examples of activity guided isolation. See, there are two types of isolation methods are available in the nature product chemistry. One is called activity guided isolation. Second is called general isolation method. So what is the difference between activity guided isolation method and general isolation method. We'll see in the next slide. If this extract is active on the biological activity, we can separate the different compound from this crude extract by different solvent. For example, if we first use hexane for extraction, dry them, send for biological activity, and this from this crude hexane extract, we can further partition with different solvent like toluene, ethyl acetate, chloroform, methanol, water, etc. And we will get a different extraction. We have to send this different fraction for biological activity. Out of them, any one extract or fraction will show the activity. Others are not. Why? Because which compound are responsible for this activity are present in only one fraction. If a chloroform extract shows the biological activity, then and then further the chloroform extract will go or will subjected to isolation study or a separation or isolation study. So we will get from this study pure compound. If we get a 15 types of different pure compound, we have to send for again determination of biological activity. From this, any one compound will give a active lead compound. You can see the diagram of activity guided isolation. So we'll back to our previous slide. Here is the send extract for biological screening. Isolate compound from active fraction. Structure elucidation of isolated compound. So you all are aware about this structure elucidation process. It means I'm talking about the spectroscopic study. We are using or we will use IR, NMR, mass, X-ray, etc. The next step is send pure compound for biological screening, and then hopefully active molecule found or not. So this is the different steps of hunting for the active molecule. First, again I repeat: plant collection, drying and grinding, extract the sample with various solvent, then send extract for biological screening, then isolate compound from active fraction, then isolated compound send for structural elucidation, then pure compound for biological screening, then hopefully active compound may be sent. So this is the different steps of activity guided isolation. We can use the different extraction method in the plant or any living organism. This is not our today's topic, so just it's with the name or list of the extraction method. It's of maceration, decoction, percolation, substrate, countercurrent extraction, sonication, supercritical fluid extraction, and steam distillation. From this substrate extraction, that is a very powerful technique. Also, it called a continuous hot extraction method. This is the extraction method, And this is the separation and isolation method. We can use the different isolation method like separation method, centrifugation, distillation, crystallization, filtration, and last chromatographic technique. This is a very powerful technique for separation and isolation method. Today we are using this technique for in the plant research. In chromatography, there are many chromatography are available: TLC, Coulomb chromatography, HPLC, HPLC, GC, UPLC, UHPLC, flash hyphameter technique like GCMS, LCMS, etc. This is the depending on which type of compound present in the extract. This is the example of activity guided isolation, and this is the example of general isolation. In general isolation, we are not focusing on activity of the plant. We are just focusing the plant molecules. Either it give a activity or not. It is not a concern. We are just looking for new molecule from plant. You can use this technique also, because in this technique your priority is not a activity. Your priority is just a molecule to isolate or characterize molecule from plant. You can take a different extract, different types of class of compounds. If you want to work on steroid, then there is your interested class is steroid. Other compound are not interested. So here activity is not a focusing. Different structure determination by different spectroscopy method. Just this is the just a list of the spectroscopy: UV, IR, mass, NMR, X-ray, etc. From this, what we get? We got a molecule. Is it active? Don't know. How we confirmed it? By bioactivity. What is bioactivity? In pharmacology, biological activity describes the beneficial or adverse effect of drug on living matter. It's called bioactivity. There are two types of bioactivity. One is the in vitro bioreactor, or second is the in vivo. Already you studied this type of activity, or you heard the name of this type of name in vitro and vivo in your PG or UG. In vitro, in experimental situation outside the organism, biological or chemical work done in the test tube. In vitro is a Latin. It means in a glass rather than a living system. Examples include antifungal, antibacterial, organ-based assay, cellular assay, etc. What is in vivo? Tests performed in the living system such as anti-diabetic assay, CNS assay, anti-hypertensive assay, etc. So this is the example of activity. If it is a biological activity, and take a clinical trial. If it is if we will get a success in the study, then it is a drug molecule or lead molecule. So this is the one exercise from plant to drug. This is the structure of plant. What is the first step? We already discussed in plant hunting step. Is the different steps. It is just a picture, but it will take more time, more money, hard work. So this is the from plant to a living molecule. You can see plant drying, extraction, biological activity, crude extracts, fractionation by solvent, separation. If you get a pure compound, it's a biological in vitro and in vivo. Either maybe food, drug molecule. So this is the basic introduction or basic. Uh, it is not possible to understand all these phenomena in a one lecture. This is just a primary introduction and a primary. We can think about the topic. We can have an idea about how we can start our nature product research in chemistry. So this is just a fundamental introductory lecture. If anyone have a question, they're gonna ask. Otherwise, we'll go to lecture here. Any question from your side?
Maybe not, sir.
Okay.
Okay, okay, sir. So, shall we complete, sir?
Yeah, no problem.
Okay. Thank you so much, sir, for this lecture.
Thank you.
Okay, sir. We can leave now.
Okay.